everyone, it's good to see you all again. I'm Natasha and welcome back. So today we'll be continuing our 7th chapter, which is Permutations and Combinations. So in this video we'll be discussing about the fundamental principle of counting, as I've already told you about this. And in the previous video, as I told you something, I told you a little bit about these principles. So I told you that there will be two types of principle. First one, which will be related to the multiplication principle, and second one, addition one. Okay. So, and I also gave an example. That example was exactly not right, as I told you already. Because I just wanted to tell you that. In first principle we'll be having like two ways in which we'll be adding them or multiplying them, whatever you can say. In the second principle we'll be having two ways, but there will be another condition related to it, and then we'll have m plus n ways or m into n ways. So first principle I'm taking it as multiplication principle, and second one is going to be addition. Okay, right. So according to the first principle, I'm going to have m into n ways, and second principle m plus n ways. Now let's find out what's the difference between these two principles and nothing else. Yeah, so let's get started. Okay, so I've already written these two things as there was nothing hard in it, so I just wrote it. Yeah, so what is the first principle saying? So it is saying if there are n ways to do one thing and n ways to do another thing, then there are m into n ways to do both the things. So what is it saying? That if we have m ways and n ways to do one thing, and that thing can be that thing is actually, there are actually two things, okay? So those two things can be done at the same time. So what we'll be doing is that we'll just multiply those ways. So m ways into n ways, right? This is what the first principle says. Okay, so now the second principle, which is the addition principle. So there's something a little different here, so let's just see what is it. If there are m ways to do one thing and n ways to do another thing, but one thing that both can't be done at the same time, then there are m plus n ways to choose one of the things. Okay, so what was in this principle is that there were like two things, okay, and we had two ways for that. One thing that both the things can be done at the same time. So one of whether like one thing will be done first or the second one, okay, but both can be done at the same time. So that is why we have used m plus n ways. Okay, m plus n ways. Here, if we have a condition where we can see that those things can be done at the same time, like we can do those things at the same times, then there will be m into n ways. And if both the things can be done at the same time, then there are m plus n ways to do one of the thing, okay, but not the both things. Okay, I hope this is clear, right? So let's move on. Should I take some examples? Should I? I guess I'll be taking those examples in the next video. Okay, so one thing that I want to say is that we'll be studying about the type 1 and type 2 permutations. So in which, like, how do we denote a permutation? Okay, so we've actually already discussed about what's basically permutation. But how do we denote it? denoted. Okay, so what so this is like this is how we denote in permutation. So NPR, right? So this is the way. So number of permutations, this R is for, I can just say that number of permutations of n different objects taken R at a time where 0 is less than R and R is less than or equal to n, and the objects do not repeat. So basically what I'm saying is that this n is for the number of permutations of n different objects and taken R at a time. So we'll be discussing these things later. So number of permutations, yeah, so I was saying number of permutations here, NPR. Okay, this is clear, right? So number of permutations, you're taking in like n different ways, taken R at a time. Okay, so NPR, how do we denote a combination? Don't worry, because we'll be discussing about this type 1 permutation, type 2 permutation in next video. Actually, I thought, I thought to take some, questions too, related to these principles. So, okay, how about, okay, so let's discuss this. Why don't we take a question? It will be more easier for us. Okay, so one thing that I want to tell you, before moving on to the question. Yeah, so NPR is for the permutation. How do we denote a combination? NCR, it is exactly the same, okay? Just at the place of P, we'll put C. Okay, this is for the permutations and this is for the combination, okay? Right? Okay, so these two things are clear, and so let me just clean this board and then we will do a question related to this principle. Okay, let's do this. Okay, so first let me clean this, and you'll have to wait for a few minutes maybe. I'm not exactly sure how long will you have to wait, but let's see. Okay. It is not this much, so I can just easily do this. I'm almost done. Okay, so let me first write the question and then we will be discussing that question. Alright? Got it? Okay, so let me write this question. So here I've got a question. So there are like 8 daily newspapers. There are 8 daily newspapers and 5 weekly magazines. And 5 weekly magazines published in New York. Okay, sounds cool. New York. Yeah, published in New York let me just make it a little short. Published in New York if Colin wants to subscribe. Okay, subscribe. to exactly subscribe to exactly one daily newspaper and one weekly magazine how many different choices does he have? How many different choices does he have? Let me change the marker. So just wait a second and then we'll solve the question. Okay, so yeah. So let's discuss this. So question is, if there are 8 daily newspapers and 5 weekly magazines published in New York, if Colin is a boy or gal, whatever you can say. So here Colin is a name. So if Colin wants to subscribe to exactly one daily newspaper and one weekly magazine, how many different choices does he have? So which principle am I going to use? And why? What's the reason? Can you guess it? Well, I think it's absolutely an easy question, right? I just want to make this concept clear, okay? And you know, it will be more easier for us to move on further. Okay, so what we can see is here 2 ways are given, M ways, N ways to do. If Colin has to subscribe 2 things. Okay, I mean he has to subscribe to exactly one daily newspaper and one weekly magazine. So there are like 2 things he has to do, and there are M ways and N ways, right? Okay, so then how many choices does he have? So which one am I going to use? Okay, right, yeah, I am going to use the first principle, which is the multiplication principle. In where I'm going to use M into N ways to find how many different choices does Colin have. Okay, if it's clear, then let's write the answer. So by using the first principle. And why don't we write in the bracket too, that is the multiplication principle. Multiplication principle. By using the first principle, multiplication principle, we get M into N ways to do both the things, right? If it's clear, then let's move on. So by using the first principle, we get M into N ways to do both the things. So as we have to, as Colin has to, Colin wants to subscribe to 2 things, okay? One daily newspaper and one weekly magazine. So they like to do both the things. So for that, we will multiply the M and the N ways, okay? So what is the M? M is going to be 8, N is going to be 5. So M into N ways or choices, whatever you can say. Let me just erase this. M into N is equal to, M will be 8 into 5. 8 into 5, which will be 40, right? Isn't it? Yeah, so it's going to be 40. 8 into 5 is equal to 40. So, right. Now we can say that Colin will, Colin have 40 different choices. That's what I can write, right? So it's really easy, and this question was super fun. So let's take a small example again. How many positive divisors does 2000 is equal to? 2 to the power 4, 5 to the power 3 have. Okay, how are we doing this question? How many positive divisors does 2000 is equal to? 2 to the power into 5 to the power 3 halves. Okay, let me write this. So positive divisors, and just saying that 2000 is equal to 2 to the power 4 into 5 to the power 3. How many positive divisors does this have? Okay, so this is actually a kind of, I don't know what exactly to say right now. So I'll just say this. We'll discuss this question in the next video, and whatever the main topic is, we'll discuss it, from next videos. Okay, so I think that is enough for today, right? Yeah. So I hope today's topic is clear to you, because of course it is clear to me, so it should be clear to you too. Okay, so that's all for today. Thanks for watching and have a great day.